Today we're going to practice finding the equation of a sine or cosine graph. This should be relatively familiar to you because we've already covered functions, and so you should know that we have a general formula for each function, and today we're covering the sine function and the cosine function, each of which has the formula a sine x plus q or a cos x plus q. Remember that A represents the amplitude, while Q represents a vertical shift. So, if you have to find values to replace that you can put in the place of A and Q, you will have to be given a graph from which you can extract information that will help you find A and Q. Now, A and Q is a total of two variables, so you're dealing with two unknowns. That means you will need at least two pieces of information that you can substitute in that place in order to find the equation. Now, remember when we did these functions, we wrote down the formulae that A is your maximum minus your minimum divided by 2, while Q is your maximum plus your minimum divided by 2. So if you are just given a graph, all you need to do is read off the maximum and minimum values, and voila, you've got enough information to write down the equation of the graph. So let's jump straight into a very quick example. Below, the graphs F and G are sketched. So F is the blue graph, and the question tells you that F is a sine x plus q, while G is a cos x plus q. And now we need to determine the equation of each of these graphs. Now, I'm not repeating the formulae on the previous page. I'm diving straight into applying those formulae. So let's work with F first. Do you agree that the A is your maximum value minus your minimum value divided by 2? So A, our maximum value, minus our minimum value. Look at how the maximum value on this blue graph is 2, while the minimum value links up to negative 2. Hence, we have 2 minus 2. Of course, that's going to give us 2 plus 2, which is 4, and then we divide that answer by 2, and so our final A value that we're going to pop in over here, replace A with a beautiful number 2. Now, how are we going to get the Q value? We're going to say our maximum plus our minimum divided by 2. So we're going to say positive 2 plus negative 2 divided by 2. And as you can see, 2 plus a negative 2 is the same as saying 2 minus 2, which would give you a big fat 0 up at the top of this fraction, meaning our Q value boils down to 0. So we substitute, instead of having y equals a sine x plus q, we have y equals 2 sine x plus 0. And of course, you can just drop the 0. So basically, 2 sine x, the graph of f, is the original sine x graph that has been stretched vertically by a factor of 2. Have a look. We normally start, when we sketch a sine graph, we go uppy, or we sketch a mountain, and then we sketch a valley. And the beginning, the foot of the mountain, occurs at the origin. So for 2 sine x, the foot of the mountain is still occurring at the origin. So we have not shifted this graph vertically. But now look at this orange bad boy over here. Look at this cos x graph. How are we going to get its formula? We repeat the exact same process as what we did for fx. We take our amplitude is always going to be our maximum value, which is obviously 2, minus our minimum value, which is the do you see how the graph touches the x-axis? And anything that touches the x-axis will have a corresponding y value of 0. So we have our max minus our min divided by 2. 2 minus 0 divided by 2 gives us a glorious number 1. Same process to get the Q value. We're going to take our maximum, add it to our minimum, 2 plus 0 divided by 2, gives us a big fat 1, and so our final answer is gx equals 1 cos x. The a value we pop in there, plus 1, the q value we pop in there. Note that you don't have to write the 1 in front of cosine x, because if your coefficient of a variable is 1, you can just ignore it. It can be an invisible 1 up front. And that's pretty much it, guys. That's the concept of the day. Easy peasy, right? The only thing you need to do now is check out the next slide to remember the interpretations you are also expected to know how to make when you are given graphs. But I'll just Right, so remember that you need to be able to give the period, range, and amplitude of each of these graphs. So I'm not typing it up and presenting the text. I'm just running through it with you vocally. So the period, let's do the period for both the cosine and the sine x graph. Now at a grade 10 level, this is a simple, straightforward, easy peasy fact that you just have to memorize. Please, the period of a sine graph as well as the period of a cosine graph is the number of degrees through which the curve flows before it begins to repeat itself. So that you can clearly see is 360 degrees. How do I know? Because for the orange graph, I'm looking for that cup shape. I'm looking for a bowl where you keep your course, right, for cosine. So there's the bowl. How many degrees in space on the x-axis did it take up? 360. What do we do for a sine graph? We look for a mountain and a valley. Once you've allowed your eye to flow through one mountain and one valley, we end up at 360. Hence the period is 360. Range is always just an interval, starting at your smallest y value, ending at your biggest y value. So for fx, the range is y is an element of -2, semicolon, but all the way up to 2, and we use square brackets. The range for the orange is y is an element of 0, because we talk about y values when we're dealing with range, all the way up to semicolon 2, square brackets. Right, the amplitude is super easy because that's just the number that's in front of the cosine or the sine x, and we've already found those equations, so it's right obvious. The amplitude of G is 1, while the amplitude of F is 2. Easy peasy. Also, you also need to be able to state the values. And now I know this is quite an abstract kind of question, and people tend to freak out. But don't worry, it's never for a large amount of marks. And once you get it, you will love these kinds of questions because they're really easy, actually. So right here, I'm saying, for which values of x will f times g be smaller than 0? Now, what does smaller than 0 mean in basic maths? Does it mean positive or negative? Smaller than 0 is obviously negative. So that means the product of two y values has to give you a negative number. Now, you don't even have to worry about the y values at all, actually. All you need to focus on is where will f and g lie on opposite sides of the x-axis. Because don't you agree that when the one is above the x-axis while the other one is below the x-axis, we're dealing with positive y values for the one graph multiplied with negative y values for the other graph. So the product of any two y values along this stretch of the x-axis will give you a negative number. So let's just always interpret these inequalities into where is one above while the other one is below. So the x-axis, I mean. So it's clear to see here from negative 180, apologies for not labeling it, but you can see if that's 90, double 90 will be negative 180. So from negative 180 all the way to 0, we have blue and orange on opposite sides of the x-axis. So we say x is an element of negative 180, semicolon, 0, close brackets. Use square brackets because 0 has been included in the inequality. Then do you agree that all the way from 0 to 180 degrees, blue and orange lie above the x-axis? And so the product of these y values over here would give you a positive answer. So if the inequality faced the other direction, that would be our interval answer right there, 0 to 180. But because we're looking for where the product would give us a negative value, we want to look where is orange and blue on opposite sides of the x-axis. And here you can see from 180 onwards, we have orange above the x-axis while blue is below. So from 180 to 360, this segment of the x-axis must also be in our answer. So we're going to go, or x is an element of 180 degrees square bracket, semicolon, 360 degrees square bracket. And that is probably the most abstract or tricky question you could be asked. The rest is very theoretical. So I encourage you to memorize the formulae on this front slide and enjoy the exercise for today. It's super easy and you will breeze through it. Can't wait to do the tan graph tomorrow.